Hello everybody, it's Christian, and today I'm going to show you how to build a strong and powerful monitoring system for your OPNSense firewall using Prometheus and Grafana. Now, some of you might wonder, why the heck do we even need this? Because OPNSense already has a built-in dashboard where you can see some statistics about the system's health and performance. Or there's even a reporting menu where you can check in the different graphs and change the granularity, scroll back and forth, zoom in and zoom out. So the question is, why do we actually need a different system? Well, one of the biggest challenges or the use cases where you would want to take a look at these statistics is when there is a problem. So when you need to troubleshoot maybe a system outage or a degraded performance, maybe you have some high latency on some network interfaces or only on specific network protocols, and you just want to find out what was causing this issue. So then it's really hard in the default dashboard, because even in the detailed health reporting system, you can only see one statistic at a time. And for example, if there was a huge spike in the CPU utilization and you want to find out, was that happening at a time where there was a high network traffic, you always have to go back to a different panel, and you cannot really compare and correlate these metrics at the same time. So therefore, I think it is much better to have a centralized monitoring system where you can select time frames. For example, if there was a high CPU spike, and it will automatically correlate this with other statistics where you could find out, oh, this was at a time where there was a high network traffic, or maybe it was at a time where a service was failing. Maybe you even have multiple OPNSense firewalls that you all want to monitor at the same time, and you even want to customize all these settings, like changing these panels, or even go into the details like changing queries and customize these dashboards. Well, this is exactly where Grafana and Prometheus come into play, because they provide you a more centralized and more powerful and more customizable monitoring dashboard where you can much better troubleshoot what was going wrong. So that's exactly the plan for today. Of course, as you can imagine, there are a few different technologies and components involved into making this possible. Here I've created a high-level diagram for you to better understand how these components all work with each other. Some of you might see some familiar names here, like Prometheus and Grafana. I hope you all know, because otherwise it might be a bit hard to follow this one. I still try to make it easy to follow, but of course I'm also preparing a list with other video tutorials about all these other technologies, so check it out if you like. But to quickly explain what you're seeing here, so on the right side we have our monitoring stack with Prometheus. So this is the time series database where we can store all of these metrics that is later easy to search and easy to visualize with a tool like Grafana. So this is the web interface where you can build all of these dashboards and panels. It's actually just accessing the database backend on Prometheus. And on the left side, we have our OPNSense firewall, where we want to gather some metrics about the CPU, memory, disk utilization, or about network interfaces. These are very general system metrics that are usually the same for every Linux operating system. But there are also a few very OPNSense specific metrics like gateway events, services, and so on. And to collect those events and get them into our Prometheus database so we can later visualize them, we need a few components. First of all, we will install the OS node exporter, which is effectively just collecting all these metrics here above. I've also found a nice open source community project there for collecting very OPNSense specific metrics that are not provided on the Linux kernel. So this will constantly connect to the OPNSense API, query the information, and also provide them in a Prometheus standardized format. And then we will use Grafana Alloy. This is a small service application that also runs on a collector endpoint, and this will constantly scrape the metrics provided in this standardized format from both the operating system's node exporter as well as the API exporter, and scrape this every 15-30 seconds and send these metrics all to the Prometheus database where they are ingested and stored over time. So that's roughly the plan for today, and the system that I found out to be the most reliable one to scrape all these metrics. But before we jump right into this topic, I want to say a few words about the sponsor of today's video, TwinGate. This is my absolute favorite tool for remote access, and always my first choice when I need to log into my home lab servers over SSH, or if I need to access my administrative tools, like my Kubernetes clusters or my Git repositories. It's a great defense against any form of web-based attacks, supports DNS filtering, content filtering, and provides privileged access across your entire network, cloud, and application infrastructures. It's what we call ZTNA in tech, a Zero Trust Network Access platform that establishes secure connections between all of your devices, where every single request has to be verified and authorized, otherwise TwinGate will just block the request. And this technology even works through NAT devices and firewalls without any port forwardings or firewall exceptions required. And the best, it is completely free for up to 5 users, 10 remote networks, and 20 different resources. So you can just try that out in your own home lab. Of course, I've made several tutorials about TwinGate and how to install this. So start making your network more secure and accessible. Of course, I'll drop you a link to TwinGate in the description box down below. Alright guys, so now let's get back to OPNSense monitoring. For this demo tutorial, I want to rebuild this entire stack so you can just easily follow along, except for the OPNSense firewall, because I'm already running an OPNSense firewall in my home lab, and this is actually responsible for my entire network to function. But the other collector components and monitoring stack, I will completely rebuild from scratch here. Of course, I don't want to start from zero, so therefore I will use my boilerplates project. For anybody who don't know the boilerplates project, I'm maintaining a Git repository with a template library or a template collection where I'm storing all of the Docker Compose files, the scripts, and deployment templates that we are covering in this tutorial videos. And I've already created a simple CLI program that you can easily just install on your Linux or Mac system. You can even run this in WSL2 on a Windows machine with this single command here. And then you can just execute boilerplates in your terminal. This will give you access to my entire library for all of the Compose, Terraform, Kubernetes, and other tutorial templates that I'm creating and providing. If you just installed the tool, don't forget to run a repo update. So this will synchronize and pull down the latest changes on my template library to your local workstation so you get access to everything. And then with the boilerplates compose list command, for example, you can get a list of all the templates you have access to, such as the Prometheus template or the Grafana template. There's also a Grafana Alloy template that you can use to quickly get started so that you don't have to go through the official documentation and search for a Docker Compose file if ever the developer provides them. By the way, I'm running the entire collector and monitoring stack on my local Mac in a containerized environment. But of course, you don't have to run this on a local workstation. I'm also running my production system on a small virtual Ubuntu Linux machine. So there I'm running Alloy, the API exporter, and Grafana and Prometheus, of course. So we are not touching my production environment for this video. But yeah, feel free to deploy this anywhere you like. It should always run on any Linux machine that has the Docker engine installed. All right, so let's prepare my demo setup. I'm going to go into my temporary directory, and I think I've created a new directory called OPNSense Monitoring. I'm going to open this in VS Code because I'm going to start, as always, with a compose.yaml file, so where we can store the entire configuration for this monitoring and even the collector stack in one single Compose stack. I think that's the easiest way to do this. And usually the way how you would work with my boilerplates CLI tool, you generate a template like Prometheus. I will use the dry run parameter with show files. So this will not write the files, it will just output them on the terminal in the no interactive mode. So this will print out some details about the template with a link to the documentation project and all the variables this boilerplate supports. And then it will print out the file content. So here's the compose.yaml file for Prometheus and a simple configuration placeholder. So this you can extend with your own Prometheus configuration. Now, one thing that we have to customize here, and this is quite important because by default, Prometheus does not allow sending or pushing metrics to it. By default, Prometheus is usually scraping metrics from target metrics endpoints. So that means usually you would connect from Prometheus to your API exporter and to your OS node exporter on the OPNSense firewall, and not the other way around. But in this setup, I've added Grafana Alloy as a central metrics collector that will scrape these two sources and then send it to Prometheus. Theoretically, you could do it without Alloy, but Alloy provides some nice features for changing labels or changing field names, adding certain values or filtering and stuff like that. And because for this OPNSense monitoring setup, we need to relabel a few fields or add a few values to this, I thought it might be easier to just throw Alloy in the mix. To make it easier for you, I've added a variable in my boilerplates library for this. This is called metrics enable remote write. So this will allow pushing metrics via the API endpoint to Prometheus. By default, it is set to false, but you can easily enable this with a --var and then the variable name and set this to true. So then we will regenerate the boilerplate for Prometheus. Then you can see that there is a new config line added here, web enable remote write receiver. So by adding this command flag to your Prometheus container, if you're modifying your existing Prometheus instance, for example, you can allow an external target sending metrics or pushing metrics through Prometheus. But be careful when doing this. Of course, this enables anybody to just send something to your database. So make sure that the Prometheus instance, when you're enabling this, is itself protected somewhere or only running in a protected local network and not accidentally exposing this to the World Wide Web. So that's quite important. But here we can just copy the generated file content and put this in our compose stack. Usually, I think we will just need to generate this config file here. So this is mounted through config. I will add config Prometheus here because I will later add some other config files. So this is what I'm modifying a little. Prometheus and then say prometheus.yaml file. And in this config file, we can just copy some of these placeholders here. I think we will just need this minimal configuration file, the scrape configs jobs. So here you would define the configuration for Prometheus to scrape the sources, but we will leave this empty because we don't need any jobs here. And the scrape interval 15 seconds. Yeah, I think that's fine. Usually we don't need anything in here, but I think we need some general configs. Otherwise, the container probably won't start. But I don't really know, but yeah, we will see. And yeah, so to just go on, I will generate another boilerplate for Grafana. Of course, Grafana doesn't have this variable here. And I think we don't need to modify anything else because as you can see here in my boilerplates, you can also configure a bunch of other settings like single sign-on with authentic, traffic reverse proxy. That will add the traffic labels to the containers or a database, Docker Swarm settings and stuff like that. But yeah, I would just go with the defaults. This provides a minimal configuration for Grafana that we can use for our demo environment and yeah, put that in here. Of course, I need to change the volumes a little. And as Grafana is super simple, it doesn't have any configuration file. It uses an SQLite database. So we will store this in a persistent volume. That's totally fine. So that should be enough for the right side, the monitoring stack. So let me just try running this. Hopefully I don't run into any errors, but we will check with Docker Compose PS. And yes, this is up and running. So let me check if I can connect to the Grafana dashboard login. Yes, we will log in with admin. Skip the new password generation, and there it is. Our Grafana dashboard is already running. And we can also check Prometheus with a port 9090. So this is the database, but it also has a simple web endpoint where you can query any information from the database. So there we can later see if our metrics that Grafana Alloy will scrape from the sources will actually arrive at the right place here. Currently, this is, of course, empty, so there's nothing in the database. All right, so that's at least the prerequisite. Our monitoring stack is up and running. So the next thing you need to do is you need to install the OS node exporter on OPNSense. Luckily, this is super simple, so I will just show you when I connect to my OPNSense firewall. The OS node exporter you can simply install with a plugin. So just go to System, Firmware, Plugins, and then search for OS node exporter. There it is. You can see I've already installed this on my OPNSense firewall because, again, I've already used this for my production setup. But usually you just need to search for this, then you need to install. Make sure that you have the latest version of the OPNSense firewall installed, otherwise you probably need to upgrade it first. And then once you install this, there should be a new menu under Services called Prometheus Exporter. So this is where you can enable it. By default, you can add the listening address to just 0000. I've not done it this way because then the metrics of the OPNSense firewall would be exported to all of the interfaces, which is usually not a secure setup. So if you have a separate DMZ or a production setup for your home lab, then make sure to only enable the Prometheus exporter there. So no other network interface of the OPNSense firewall will get access to it. And you can also change the listening port if you want. 9100 is, I guess, the default. And then you can enable the checkboxes to expose the different statistics. Of course, if you're not using ZFS, you can disable this. Or if you want to not expose some specific statistics, you can also disable these. But these are all the statistics that the Prometheus exporter supports. As you can see, there are some general things like CPU, execution statistics, file statistics, load average, memory, network interface, and stuff like that. But it's actually not a lot. So we will later need the API exporter to provide some more insight into gateways and other services that are running on the OPNSense firewall. But that is at least the bare minimum that you should monitor, so to speak, right? Okay, so once you've done that, save this, and this will automatically start the Prometheus exporter. You can, by the way, test if this is running when you just enter curl and then just check the firewall using HTTP on the port 9100/metrics. Probably need to use the IP address here, otherwise it won't expose it, of course. So these are all of the metrics in the Prometheus compatible format. It's super simple, yeah, so you just see the metrics with the values. And every time you do a request, these values, of course, change. So therefore, you need to scrape the metrics every 10, 15, or 30 seconds and then store them in the time series database. So then over time, you see the graphs. But usually, this is just at the time of making the request. So now we can return to our setup. Now we need to extend it with the middle part here. You might have seen in my boilerplates an alloy template that we can use. So we can actually use this in a similar way like Prometheus and Grafana. I think we can just go with the default values. That should be fine as well. And here you can see a simple configuration file that we can later extend, and also the compose file. So I will just copy this here, put it maybe at the end. And yeah, of course, I need to add the volume here and remove the services. Otherwise, it doesn't make sense. And that's it. All right, no, that's not it. One thing that I'm going to change is the config file here. So actually, I think there is a mistake in the boilerplate, actually, when I see this. Yeah, I probably have to update it because the config file should have the directory before that. I will later update this so that you don't have this problem. But I need to put this into a different directory anyway, so it doesn't create a problem with the Prometheus config file. So at config alloy in here, and there it is. Okay, so there we have everything. We have Grafana Alloy, and we have our config file. So now we need to tell Grafana Alloy to scrape the metrics from the OS node exporter. Remember, we just made the query here at this address. So this is the address where the metrics are available. And in the configuration file, we first of all should configure the target. So Prometheus remote write. So this is to send the metrics to a source. We can give this a name, but I usually just keep the name default. If you have different Prometheus instances, you can give them all a name, and then you can later in Alloy define to which instance you want to say send what log message. But here we just need one that is default, where we define the endpoint with the URL /API version 1 write. So this is the address that we need to use. Make sure that this URL, of course, matches the container name. And you also need to make sure that Prometheus is running in the same Docker network as Grafana Alloy. Otherwise, if this is running on a different machine, you have to use the IP address of your server where your Prometheus instance is running. And you also need to expose the port 9090, of course. Now we need to scrape the metrics from the OPNSense firewall. So we need to create a new Prometheus scrape job. And we will call this OPNSense node, because we will later need a different job for the API. Actually, GitHub Copilot is now completely confusing me instead of actually helping. we need to define a more complex object with the address OPNSense. Yeah, that's of course just a dump placeholder. So now we need to use this address here, the target, so the IP address / metrics. Actually, the Prometheus scrape job just needs the IP address. It knows that it will use the / metrics, so not the URL, the address of the server. And now we can make some adjustments to the fields or the labels of the log files. For example, if you want to give this an instance name, you can name this OPNSense node, or you can say firewall OPNSense 1 or OPNSense 2 or whatever. You can also give this a job name. So this is, I would definitely give this a job name, because otherwise you cannot in the dashboard later easily differentiate between the different jobs. You can also add this to a group, maybe OPNSense, or even better, call this firewall, because you might scrape metrics for other firewall vendors as well, and then you can all have them in one label group, and you can later better filter or search for something specific. You can also add a host, for example, so this will be the host name of your firewall. In my case, it is firewall prod1, for example, okay? And then, after the target's configuration, we need to forward this to, and here we refer to the name of the target's object. So just say Prometheus remote write and then .default, or whatever you have entered here in the quotation marks as a name for this object. And you can also customize the scrape interval here. For example, if 15 seconds is a bit too short, you can go to 30 seconds or even to 1 minute or so, and also give this a scrape timeout. So this, of course, is when the firewall is unavailable, or if you have latency problems or whatever, you can increase the interval and timeout. All right, but that should be everything. Now what we can do is we can docker compose app-d. This will pull down the container image of Alloy and start this. And then we should directly see that there's something happening or arriving at our Prometheus database. All right, so first of all, let me check if, okay, that's restarting. That's not good. Maybe I've done something wrong here. I'm missing comma. Oh, yeah, okay. After every line. And I made another mistake. Of course, I need to refer to the object receiver. All right, so now Grafana Alloy is up and running, and it should actually already perform scraping the metrics and sending them to Prometheus. So let us check, just refresh the Prometheus database and go to these 3 dots here, explore metrics. There you should see metrics appearing. Okay, great. Honestly, I'm not an expert in PromQL, so I don't really know how to query these metrics here in a meaningful way, but as long as you see something in here, you know that these metrics are actually arriving at the right place. So we've basically done this here, we've done this, and this here. The only thing missing is the API exporter here. Because again, these statistics are great as a starting point, but it's not providing any information about the specific services on the firewall, about the gateways. Yeah, and maybe you want to monitor the gateway status to get notified about when your gateway went offline. For example, when you have a traffic outage somewhere at midnight or so, and you want to know, at that time, was the gateway online or offline? Or maybe there was a high latency between the gateway and the firewall. But luckily, I found a super cool community project. Of course, I will put it in the description box down below. This is from AthenaMind, the OPNSense exporter. This constantly connects to the OPNSense API, gathers important metrics, and provides them in a Prometheus standardized format. So here is also described how that works. I think the developers even maintain a Grafana dashboard to visualize these specific metrics here. So here, for example, you can see the gateway RTT and the gateway health status. So there you can exactly monitor all the different gateways, but it's also providing some other statistics like an ARP table, which might be sometimes useful firewall statistics, traffic, DHCP leases, IPsec, OpenVPN, and stuff like that. So it is really super useful and provides some additional metrics that are OPNSense specific, but you often have to query and correlate against other outages and stuff like that. So this is a super, super helpful and great community project. To use the OPNSense exporter, you need to enable in the unbound collector the extended statistics. So this is something that you need to do. Let's go back to my firewall, unbound DNS. Advanced, and there it should be, there it is, yeah, extended statistics. So this you need to enable, otherwise it won't work. And then the usage is pretty simple. You just deploy this as a simple Docker connector. Make sure that you set your API key and your API secret and your instance name, and then expose these metrics on port 8080. And this you can later again scrape with Alloy and send to Prometheus. So that's how we can do this. All right, so I'm gonna use this example here for Docker Compose, of course, because we already have a Compose stack running here, so it's not difficult to add this one here as well. For the API key and secret, I would strongly recommend you to use environment variables, so better do it like this here, API key, API secret, and then create a .env file where you set these values. All right. So once you have that, you of course should also customize your instance name. For example, the label can be OPNSense main or OPNSense firewall, whatever. And the address, of course, is the IP address of your firewall. If you're using an insecure TLS certificate, you can also add this here, OPNSense insecure. So then you're skipping the certificate validation. That's also sometimes useful. And you can disable specific fields like the ARP table, the cron table if you don't need that, but usually we want to expose all metrics and later in the dashboard we can filter what's important to us and whatnot. So that's what I would always do. Okay, so the restart policy. I'm not a friend of always, so I'm setting this to understopped. And yep, no, we just need to create the API key and secret. And the way how that works is also pretty simple. You just go back to your firewall and go to system access users. I would create a new user for this, Prometheus exporter, for example. Then you can easily create an API key and secret for this user when you go to this field here, create and download API key for this user. So here are the credentials. Of course, I'm going to put this into the environment variable file in here. And yeah, then we also need to give this user permissions. So you can just click on edit and then go to privileges. I personally have just added all pages, but you could specifically enable certain diagnostic settings. Then you of course have to know which ones there are. I think in the documentation there is a hint which fields you have to enable. Yeah, there's user permissions. So these are all of the settings that you need to enable. But yeah, because I'm lazy, I just enabled access to everything. That should also work. And then there's one more thing for the gateway monitoring. I just found that out later because it isn't described in this documentation. But if you want to monitor gateways, you need to go to System Gateways Configuration. And for example, I'm using a DHCP gateway where the monitoring by default was disabled. So I was wondering why I didn't get any metrics in the dashboard. So I removed this checkbox and added the monitoring IP of the upstream router, so the internal IP address of the Fritzbox or whatever you're using then. But you need to make sure that you're not adding a failover or failback state. So that is needed usually when the gateway is offline, that the internet connection is then initiated through a different gateway. But if you just want to see if your gateway is online or not, you still have to uncheck the disable gateway monitoring, adding the IP, and just don't check any other failover stuff and so on. And you can see on your dashboard if your gateway is currently online. The only thing that is still missing is the scraping job. So what we need to do is, and I'm going to be lazy, of course, I'm just going to copy paste this here, say exporter, and change the port to 8080. And this, of course, is not scraped from the firewall directly. It's scraped from the container. So we can use the container name for the Grafana Alloy configuration. And I also want to change a few things here. For example, the instance. Yeah, we can actually use the same names, but the job should be OPNSense exporter or API exporter or something like this, yeah. So now we just need to restart the Alloy container. Let's check the logs if everything works fine. And now let's go back to Prometheus and let's go to explore metrics. So I don't know if you remember from what we've scraped before, but you should see more metrics appearing here as before. So it's just putting them all in a huge database, and we can later filter based on the different labels, the different field names and stuff like that. So I think the new metrics should be in there. And now we have basically done everything. So we are scraping all the metrics from the OPNSense firewall and ingesting and storing this in Prometheus. Now, we just need to visualize them. That's why we have Grafana. First of all, you need to add the data source. I hope you remember this from my Grafana tutorials. If not, you can check out the Grafana tutorial. So Prometheus, let's add the new data source. Of course, this is called Prometheus 1990. So now that we have this as a data source, we can go into the drill down. If we go to metrics, you can see these are all of the metrics from the Prometheus database. But of course, this doesn't provide a good overview. Yeah, and Grafana is so flexible that you can select or query specific metrics and correlate them or visualize them in reusable dashboards. And as you might have remembered, in the Athena Mind OPNSense exporter, there is a Grafana dashboard or a link to a Grafana dashboard that we can use. So if you follow this link, it will go to the Grafana's homepage where you get the boilerplate or the template of this dashboard. The way you can import this super simply in your Grafana dashboard is you just either download the JSON, so then you can get into all of the details of the objects, or you just copy the dashboard ID and in your Grafana's web interface, click on New, Import, and then enter the ID of the dashboard. And then you just need to select your Prometheus data source, import, and that's it. Now you have the dashboard already in there with the gateway status, with the gateway RTT, with the service status history, and you also have the interface received bytes by interface transmitted bytes. You have the MTU values for all the interfaces, and you also have the ARP table with the MAC addresses of the devices, which might be sometimes pretty useful for troubleshooting. But just like I said, this is very specific to the OPNSense exporter or the code or the metrics that the OPNSense exporter scrapes. If you want to see the general metrics like CPU, disk, memory utilization and stuff, you would have to build your own dashboard or search in the Grafana marketplace if there is a dashboard. I found one. This is actually not the best dashboard, to be honest. Yeah, there are a few things here and there wrong and don't look so great, but you can use this as a starting template and then build your own dashboard if you like. This dashboard, for example, shows you the uptime, the CPU idle, the available memory, the free swap, the temperature, processes, interrupts, and some other interface statistics. Yeah, here, for example, don't be surprised if you see no data. This dashboard has, for whatever reason, WAN interface 1 and 2 and a LAN interface 1 and 2, and you just need to enter the RE1 or RE0 for the Realtek or ETH0, whatever you have, and then it's showing the statistics. However, yeah, I don't have a second WAN interface, and I have more than 2 LAN interfaces, so therefore this dashboard isn't really the best one in my opinion. But I'm currently preparing my own Grafana dashboard. It's not complete, but I can show you what I'm building, because my goal is to create a dashboard that shows not just the CPU, memory, and load stuff, but also file system utilization, VLAN traffic, and then passed and blocked packets that are shown here, or TCP protocol statistics. Because the funny thing is, the data is all visible here in the metrics, just the dashboards are not visualizing every aspect of it. But yeah, you need to be a little more patient. I'm currently developing this template. Once I'm done with my dashboard, I will of course share this on the Grafana's marketplace, and I will make another video probably about how to create your own dashboard and how to customize and query things using PromQL. But if you already follow this tutorial, you at least have a starting point. You already have your metrics already ingested. You just need to experiment with the dashboards and change it later or import another one, you have the foundation to do all of this stuff with your OPNSense firewall. So I hope you liked this tutorial and it was helpful. Please let me know in the comments what would you like to see, and if you would like to collaborate on creating another dashboard, maybe that would be nice. Or if you have other suggestions for my boilerplates library. Here, for example, is an issue with a wish list for coming versions. So just add a comment in here, put in your favorite application in here, and if you want to collaborate on this project, feel free to do this as well. That would be really nice. But yeah, I think we're already over time. That's it for today. Thank you so much for watching if you've made it to the end. Thanks so much to all the members and supporters of my channel. You guys are just amazing. And I'm gonna catch you in the next video. Take care. Bye-bye.